Now, if you're like my millions of fans, or like the dozens of fans that I have, then maybe you want to visit me. So to get to the college, use the following directions. From the observation deck of the Empire State Building, if this was the only way to get to the college, it would be difficult to get there. But what if you could start from somewhere else? A useful rule in math and life: the more places you can start, the easier it is to reach your goal. And that's the value of logic. We can rewrite a statement as a logically equivalent statement. If we can find the truth value of any of these statements, then we know the truth value of all of them. And one of them is probably going to be easier to work with. Now, we might not know which one, so if we begin working with one and run into difficulties, we might try working with the other instead. And the equivalence of a conditional and a disjunction means we can convert the one into the other. For example, let's rewrite as a conditional: X is either glurby or fromulous. So our statement is a disjunction. Either X is in the set of glurby things, or X is in the set of fromulous things. Now remember, the conditional if A then B and the disjunction not A or B are logically equivalent. And so we can take our negation. We don't have a negation here. Well, remember, you can have anything you want as long as you pay for it. And here it's useful to remember the double negation, not A, is logically equivalent to A. Or is it? You should verify that it actually is. So we need a negation, so we'll use a double negative. So, for example, we might take X in G is not the case that it is not the case that X is in G. But if it is not the case that X is in G, then we could just write it as X is not in G. And so now we can rewrite this as a conditional. If X is not in G, then X is in F. Or in words, if X is not glurby, then X is fromulous. And it's important to note at this point, we're not claiming that this is true or false. We're just claiming that this is an equivalent statement. So if we know the truth value of the one, we know the truth value of the other. And remember, solve it again. We could have negated the other term, X in F. Well, that's the negation of not X in F, or in other words, the negation of X not in F. And so we can rewrite our disjunction as, which we can read as a conditional: if X is not in F, then X is in G. Or in words, if X is not fromulous, then X is glurby. Now suppose we want to determine if a disjunction is true. We can always find an equivalent conditional. If we can decide the truth value of the conditional, it gives us the truth value of the disjunction. But what if we have a conjunction? We can't convert a conjunction into a logically equivalent conditional. But we can negate the conjunction. This gives us a disjunction, which can be converted into a conditional. And so we have a lot of options. If the conditional is true, then the disjunction, which has the same truth value, is also true. But remember, that's a negation of the conjunction, so the original conjunction is false. And if the conditional is false, the disjunction is also false, which means the original conjunction is true. We'll call the conditional we obtain from the negated conjunction an associated conditional. So let's find an associated conditional. X is fromulous but not quasit. We can write this as, now De Morgan's rules change conjunctions into disjunctions. So the negation of this statement is going to be the disjunction of the negations. And so that will be, and we'll write this a little bit more simply as X not in F or X is in Q. Now, since our negation is a disjunction, we can rewrite it as a conditional. To make it a little easier to do that, we'll rewrite it so we have an explicit negation. So let's take this x not in f. That's the same as not the case that x is in f. And so our conditional becomes if x is in f, then x is in q. Or in words, if x is fromulus, then x is quasit. We can also introduce a double negation. So again, we'll take our disjunction and let's double negate this second term. So it becomes not the case that x is not in q. And so this can become the conditional if x is not in q, then x is not in f. In other words, if x is not quasit, then x is not fromulus. And it's worth noting this is just a contrapositive, and we could have gotten it that way, but we can also get it by manipulating the symbolic logic. The important thing is that determining the truth value of any of these statements will determine the truth value of all the rest. And this gives us several potential starting points.